Okay, today we're going to talk a little bit about the small jet lathe. We'll cover this lathe because we have more of them than we do any other. And the parts of a lathe are pretty much universal. It doesn't matter the size of the lathe. The parts are the same, the function is the same. It's just on the larger lathes you can use larger pieces of wood. So we'll do that on the small lathe. We're going to cover all of the parts. It's important that everybody know the correct nomenclature for both the lathe and the lathe tools, so that when I tell you what to do with a specific part, you know what part I'm talking about. And everybody calls the same part by the same name. And it just avoids confusion. So pay close attention to what they're called, because that's what we will call that part on a lathe for the whole semester. And everyone will be using the same word for each specific part of the lathe. And we'll get to that in just a moment. Now, as we begin to talk about the lathe, we will start with the business end, which would be the motor-driven spindle. This is the spindle. We'll talk about that more a little bit later. But there is a hand wheel on this side, which will turn the spindle. Inside here, there is a pulley system with 3 different pulley positions and a belt. There's a lower pulley down here that the belt is also attached to, and that pulley is attached to the motor shaft, which is under the machine. Now, we're not going to change this belt in the class. It will stay in the center position. And students are not allowed to change this belt position. So there's really no reason for a student to ever open these covers. Now I'll mention it because you'll see it on here. This is a spring-loaded locking lever. Now, to lock this, you would turn the hand wheel until the pin engages, and then it's threaded so you can engage this. And what that does is it will lock the spindle in place. And there's a place for doing that. And we'll talk about that later. The danger of engaging this locking pin is there is no safety to keep you from turning the machine on with that pin in place. And then the spindle cannot turn, and then the motor is trying to turn it, and the pin won't allow this upper spindle to move. So you wind up burning out the belt. So this is not something you need to do now. I mention it only because it's here and most people will be curious as to what it does. Do not engage this pin unless you're instructed to do so. Now we'll cover the rest of the machine in the next segment. Now from this angle you'll get a better view of the spindle. It's a threaded shaft, and this is the business end of the lathe. This is the part that's actually driven by the motor. This is where you attach everything to the lathe that's going to drive the piece of wood that you're trying to turn. The motor, as I said, is under here. This lever is the motor tensioning lever. There's a locking lever under here, and you would loosen that locking lever, and you can push down on this lever, and what that does is increase the tension on the belt. And again, that has been preset by an instructor, and students don't need to to try to adjust this. So this part of the machine you will never be called upon to touch. Now, when we look at the top of the lathe, the cast iron bed of the lathe is made up of two portions that we call ways, but it's generally just referred to as the bed. And it is flat and it is parallel to the center line of the lathe. This is the tool rest holder. It gets its name because it holds the tool rest. Now the tool rest is a separate piece, and there's a number of different tool rests that will go in here. But this is where you rest the tool when you're trying to turn. The height is adjustable, the position is adjustable. And we will get into that in great detail when we get to a couple of the other videos. Now, we will move this over here and get it out of the way so we can see everything else that we're talking about. Now, this portion right here is the tail stock. The entire assembly is called the tail stock. It has several components. The inside portion that extends in and out when you turn this hand wheel is called the quill. Now the quill has a locking lever on the back, so you can lock the quill in place. And this is the quill hand wheel. There is a larger locking lever in the rear that locks the entire tailstock. So you've got the tailstock assembly. Now this entire assembly up here that includes the motor and the spindle, this is called the head stock. So you have head stock and tail stock. This is the part of the lathe that drives the wood. The tailstock is the portion that will support the other end of that piece of wood. Now, the controls are down here. You can't even turn the machine on until you take this plastic insert and put that in place. Now you can turn the machine on. It has an automatic electronic speed control here. There's a button right here that controls forward and reverse. So you can reverse the direction of the spindle. And for students, that's not something that we do. You would never do it when you're turning from this side. There are times when you would reverse the spindle for sanding. But again, that's not something that we're going to do right out of the gate. So the forward and reverse you would leave on the forward position. The speed control is just a knob that turns back and forth. This will control the speed of the spindle from about 50 or 60 RPMs up to better than 2,000. Now, for beginning students, you will seldom turn this spindle above 1,200 RPMs. And there's a readout right here where you can actually see the speed. Now, currently the machine is not plugged in. You would take the plug, plug that in, and now when you turn the machine on, you can see the readout. Now, the spindle is currently turning, and it's about 1,400 RPMs. So for most of your work, that would be adjusted down to about 1,200. Now, It's not ever going to stay. You can't set this to 1200. You can get it in the ballpark. It's currently at 1240. If I put a tool against it, it's going to slow it down a little bit, and it might be down to 1220 or even 1200. So this is never going to be exactly 1200. You just want to get it in the ballpark. Somewhere between 1150 and 1250 is fine. And that's the major parts of the machine. We'll get into more detail into the attachments that you can put on it in just a moment. Now we'll get into some of the attachments that we can put onto the headstock to do different types of work. Now on the spindle, there are threads on the outside, and there's certain things that you can screw onto these threads, chucks, face plates, things of that nature. But on the inside is a number 2 Morse taper. And this is a spur drive, and it also has a number 2 Morse taper that is cut onto it. Now, the spur drive is what we use to drive the lathe when we're doing work between centers. And you'll understand all of these terms as we get a little deeper into the session. Now, the spur drive has 4 spurs on it that actually bite into the wood, and a center pin for alignment. Now, this goes into the inside of the spindle, and when you go all the way back, the 2 tapers engage for their full length, and you have a great deal of friction that will hold this spur drive in place. And then as you turn the lathe on, the spur drive will spin the piece of wood you're going to turn. Now, to get the spur drive back out, you actually cannot pull it out. It's a very tight fit. So you use what's known as a knockout bar. Now the knockout bar goes into the hand wheel, and then that will actually bump against the back of the spur drive. Now you don't want to just hit it and knock it out. It will fall down on the bed, and it can chip the spurs, and it can mar the bed. So you want to hold this firmly and then bump it with the knockout bar, and it just comes out. And that's how you get the spur drive in and out. Now, another one of the common tools that you will use on the spindle is a chuck. Now this is a 4-jawed chuck. It's in the box, and we're going to keep it in the box. We keep these boxes in good shape, and all of the components are in here. This is the chuck key, and you notice it's laying in here like this. The jaws are open enough for this to fit in between 2 of them. And then when you put it back in the box, it goes in diagonally, and the chuck key will fit inside the box like that. And this is the way you will do this every time you use a chuck. When you put it back in the box, you're going to open the jaws, put the chuck key in between them, and put it back in the box. The chuck key has a handle. You take the plastic piece off, slides in here, plastic key goes back on. And now you have a handle on the chuck key. The chuck key goes in the holes. It engages gears on the back side, and that tightens or loosens the 4 chuck jaws. And that's how you would hold a piece of wood on the lathe when you're using a chuck. Now it has one more attachment to it, and that's called a worm screw. Now, the worm screw is used primarily in bowl turning, but it has other applications as well. And this goes inside the chuck jaws. Let me go ahead and put this on the lathe. It'll be easier to install that. There are threads on the inside of the chuck that will fit onto the spindle. Now, this worm screw, when you want to use that, it goes inside. There's a slot in here with a large portion in the back and a small flange on the front. So this goes inside. Now it has two holes on this chuck. When you tighten up something in a chuck, you always tighten both holes. That's why they put two of them. The reason for that is if you tighten up on one side, the friction involved in all of these four jaws and the gears that move them, you will apply most of the force on this side, and friction will reduce the amount of force that's put on the back two jaws. So it won't be even. So when you turn this around and tighten the other side as well, now you have evened out the pressure on all four jaws. Now, as you can see, the worm screw is protruding out past the jaws. And to use a worm screw, you would drill a hole in a piece of wood and then screw it on to the worm screw. It comes in contact with all four jaws and it's held securely. And you'll see that in detail when we turn the first bolt. But that's how you would attach a chuck and now we're going to put it back exactly the same way. The worm screw goes in its own hole. Now, to get the chuck off the lathe, there's a pin in the back that's spring-loaded that will lock the spindle. Now, you can then turn the chuck to get it off the threads. Now, you would open that chuck sufficiently to fit the key inside. You would put the chuck in the box with the opening on a diagonal. Take the handle out of the chuck key and you drop the chuck key in. Now you can close the box. Now, we keep the chucks in these boxes for a reason. We want to keep all the parts together. And when you get a chuck, you would take the entire box, you would go to your lathe, you would use it, and when you're done, you're going to put it back so it looks exactly like this. And that way we keep the boxes in good shape. These boxes are 2 years old now, and they're still in good shape. And we're going to continue to use them. So we need to keep these boxes in good shape. So please do that for us. Now, we'll switch over to the other side and we'll show you how you attach things to the tailstock. Now, primarily, you're going to use one attachment to the tailstock, and it's going to be what's called a live center. Now, because the wood is spinning and it's driven from the other end, this side also needs to be able to spin. So there's a bearing in here, and the entire front portion of the live center rotates with the work. It has a cup that bites into the wood, and it has a pin in the center. And it goes in a number 2 Morse taper, very similar to the spur drive. And now it's in solidly, and you would simply move the entire tailstock up to your piece of wood, align the center pin with the center of your piece of wood, and then you would advance the quill with the hand wheel until the piece of wood is held securely. Now, to get the live center out, you don't use the knockout bar the way you do in the headstock. The tailstock assembly has what's known as a self-ejecting mechanism. As you move the quill back, it will hit a place where it seems to stop moving. Now, the end of the live center inside the tailstock has hit a stop, and if you continue to turn the hand wheel, it will break the friction in the number 2 Morse taper, and this will come out. This is in firmly enough to where you can't get it out by hand. But if you simply move the quill back into the tailstock, it will break the friction and the live center will come out. Now, you notice that while I did all of this, the machine was unplugged. Anytime you're working on the lathe, when you're changing attachments, particularly on the headstock, you would never set up a piece of wood with the machine plugged in. You would never change attachments on the headstock with the machine plugged in. You would certainly never do any work in here in the pulley with the machine turned on. So the bottom line is, if you're not actually ready to turn wood, keep the machine unplugged. When you've finished, you're going to take all of your attachments and return them to the bins that they came from. There are times when you take the tailstock completely off. Now, when you put it back on, make sure you put it on with the quill facing the headstock, not the hand wheel. It seems every year people forget which way this thing goes on. It will go on backwards. But this is the way it should go. The quill should face the headstock. The banjo will also come completely off. And you notice I did not call this the two-rest holder. The correct name for this is the two-rest holder. But in the lathe world, this piece is commonly referred to as a banjo. So if you hear it referred to as a banjo, you know it's actually the two-rest holder. This will also come off the end, and there are times when you will do that, when these parts will actually come completely off. There is a mechanism on the underside. It has a large washer with a shoulder on it. Now that shoulder fits perfectly inside the ways on this lathe. And that will slide all the way in, and then it locks by pulling the washer up against the bottom of the bed. The two-rest holder will rotate. But generally speaking, you're going to leave the lathe with the two-rest in this position, the tailstock in place with the quill facing the headstock and locked in place. You will leave with the machine completely unplugged. You take out the plastic key, and you'll take all of the components and put them back where they belong. And that pretty much concludes everything that we have to say about the small lathe. And just bear in mind that when we look at the larger lathes, the parts are exactly the same. They go on exactly the same. The larger lathes also have the number 2 Morse taper. The spindle on the larger lathes is larger. And when it comes to the chucks, you would use the chucks specifically set up for the larger lathes. They have the larger threaded inserts inside the chucks. So this is just a quick overview. The first time you get into the shop, I will go over this again, and you'll have the opportunity then to ask your questions. And that's going to conclude it for the day, so I'll see you another day on another video.